The search for the universe's first light has always been a pursuit of ghosts. For more than half a century, astronomers have tuned their instruments toward the faintest whispers in the sky, listening for echoes that are older than galaxies, older than the stars themselves. In 1964, in a quiet New Jersey field, two young radio engineers, Arno Penzias and Robert Wilson, pointed their horn-shaped antenna at the heavens. They were not searching for the beginning of time. They were merely trying to eliminate static that clung stubbornly to their signal, a faint hiss that refused to vanish no matter where they aimed. At first they blamed the equipment, then they blamed the sky. They even blamed pigeons nesting inside the antenna. But the hiss remained what they had stumbled upon by accident. Was the relic of creation itself? The cosmic microwave background? The faint glow left behind when the universe was only 380,000 years old? It was the first proof that the Big Bang was not myth or mathematics but memory. For decades afterward, this signal stood as the opening chapter of cosmic history, the first light. But the hunger for an even earlier story never faded. If light is a diary, then the cosmic microwave background is not the first page. It is the first chapter we have been able to read. Astronomers began to wonder, what if the preface, the prologue of existence, is still out there, hidden in deeper shadows? In deserts and mountaintops, far from the interference of cities, great machines were built to chase that question. Instruments like the Wilkinson Microwave Anisotropy Probe, WMAP, and later the Planck satellite mapped the cosmic afterglow in exquisite detail, tracing its ripples across the entire sky. Each ripple revealed subtle variations in density, the seeds from which galaxies would one day grow. But no matter how finely they measured, the data always seemed to stop at the same wall, the moment. The cosmos became transparent and light first escaped. That wall became known as the surface of last scattering. Beyond it, the universe was opaque, flooded with plasma, its light trapped in a storm of electrons and protons. No photon from that earlier age was thought to have survived. To see before the cosmic microwave background, scientists believed, was impossible, yet, in the last 2 decades, instruments have begun to tease at something stranger. Not photons directly, but their fingerprints, subtle distortions in the ancient hydrogen gas that once filled the universe. As telescopes probed the low-frequency radio spectrum, they found hints of a signal embedded in the static, not the familiar voice of the microwave background, but a deeper murmur, as if from the cosmic dark ages themselves, long before the first stars ignited. One such attempt came from the Aegis experiment, a modest radio antenna planted in the barren desert of Western Australia. Its mission was simple in design but profound in ambition: to listen for the 21-centimeter line, the faint radio whisper of hydrogen atoms stretched by the expansion of the universe. In 2018, Aegis announced an astonishing result, a dip in the spectrum that should not have existed, a mark etched into the hydrogen gas nearly 200 million years after the Big Bang. The signal was colder than theory predicted, as though something unknown had drained energy from the primordial gas. For some, it was a mistake, an artifact of earthly radio interference. For others, it was the first true glimpse of an epoch older and stranger than the cosmic microwave background. And then came another puzzle. As data accumulated from other radio observatories, LOFAR in Europe, SARAS in India, hints of even earlier distortions emerged, signals that seemed to stretch back toward the very edge of cosmic opacity. They did not align neatly with the story scientists thought they knew. What if the universe was already shaping light before recombination? What if photons were escaping through cracks in the plasma, or being born from processes unimagined? Quantum fluctuations, exotic interactions, or phenomena yet unnamed? For astronomers, this was no longer a technical curiosity. It was a confrontation with the very boundaries of cosmic history. The discovery of an ancient signal, perhaps older than the cosmic microwave background itself, was like finding an inscription carved beneath the foundation of a temple, a message left in stone before the building was ever raised. It forced scientists to reconsider what they thought was permanent, that the Big Bang's afterglow was the earliest light we would ever see. Now, a new page had been found, written in a language faint and broken but unmistakably ancient. As radio dishes turned their ears skyward, stretching across continents and oceans, astronomers realized they were not simply listening to hydrogen. They were listening for something older, a memory encoded in the very structure of the cosmos, an echo from before the first stars, before the first galaxies, before the universe itself had learned to shine. The discovery was not yet certain, and the debate still rages, but the possibility alone was enough to stir the imagination. A signal so ancient it may rewrite the origin of light had been glimpsed. It was fragile, contested, and uncertain. But it was there. The search that began with pigeons in a New Jersey antenna had now reached the edge of the unimaginable. Humanity had pressed its ear to the silence of the cosmos, and the silence was beginning to answer back. The discovery of a signal older than the story of first light did not inspire celebration at first. It inspired disbelief. For decades, cosmology has rested upon a stable foundation, that the cosmic microwave background, discovered in 1964, is the ultimate relic of the Big Bang. At 380,000 years after the beginning, the universe cooled enough for atoms to form, freeing photons to race across space for the first time. This event, recombination, has long been treated as the moment light itself began its journey. Every textbook, every cosmological model, every simulation of the universe's birth has leaned upon this cornerstone. The CMB was the opening curtain of visibility, the oldest story the cosmos could possibly tell. To suggest that another signal, one older than this, had been found was to suggest that the curtain had been pierced, that the theater of creation had revealed a glimpse of its backstage. For scientists, such a claim was nearly heretical. The EDGES experiment in 2018 shook the foundations when it detected an absorption feature colder than the laws of standard physics could explain. If true, it implied that something unknown was sapping heat from primordial hydrogen long before the first galaxies had formed. Yet what followed the announcement was not triumph, but shock. Teams across the globe questioned the data. Could radio interference from Earth have tricked the antenna? Could hidden sources of noise, perhaps from nearby electronics or even from the galaxy itself, have woven an illusion of ancient light? The difficulty was not in detecting noise, it was in believing what the noise suggested. If the signal was real, it meant that the universe was far stranger than previously imagined. It meant that light was not only born at recombination, but perhaps shaped, cooled, or even distorted by forces still unknown. The coldness of the signal was the most troubling aspect. Hydrogen, floating in the young universe, should have absorbed background radiation in a predictable way. Yet the dip measured by EDGES was twice as deep as theory allowed. To achieve such a chilling effect, something would have had to drain energy from the gas, something beyond the physics in every textbook. Dark matter was immediately invoked. Invisible, undetectable, except through its gravitational pull, dark matter outweighs normal matter by more than 5 to 1. But could it also cool hydrogen, pulling heat from the gas in ways no one had ever considered? If so, then the ancient signal was not just a quirk, it was evidence of a hidden interaction between matter and darkness, a shadowy fingerprint on the universe's earliest light. For cosmologists, the implications were staggering. The CMB was supposed to be the oldest map. If this new whisper predated it, the entire chronology of cosmic dawn would need to be redrawn. The timeline of first stars, first galaxies, even the growth of structure itself, all of it would shift. The universe, it seemed, had broken its own rules. Some scientists resisted the conclusion, unwilling to accept what appeared to violate the very framework of cosmology. Others felt a pulse of exhilaration, for if the rules were breaking, then discovery was near. The shock deepened when alternative explanations surfaced. Some theorists suggested that the signal might not be primordial at all, but an artifact of something even more exotic, an echo of cosmic inflation, the violent expansion that took place in the first fractions of a second after the Big Bang. Others speculated about energy leaking from neighboring universes, Faint whispers of collisions in the multivers. What all these ideas shared was a single terrifying implication. The signal could not be reconciled with the universe we thought we knew. The tension between skepticism and wonder was palpable. In conference halls, astrophysicists debated not only the reliability of the data, but the very definition of first light. Was the CMB truly the beginning of sight or merely the brightest echo that survived? Could there be an even earlier light, hidden beneath layers of cosmic history? To admit such a possibility was to question decades of certainty, to unravel a narrative that had held strong since Einstein's equations first hinted at an expanding universe. The silence of the cosmos had always seemed obedient to theory, but now the silence was singing in an unfamiliar key. For those who listened closely, the message was chilling. The universe may not be telling the story we thought it was. A contradiction had been found etched into the most ancient signal ever recorded. And if contradictions exist at the foundation of time, then perhaps the foundation itself is not what we believe. The universe does not give up its secrets easily. When the first reports of the ancient signal emerged, many dismissed them as illusions, the kind of ghostly artifacts that often haunt radio astronomy. Yet the persistence of the anomaly demanded more than skepticism. If the cosmos had spoken, even in a whisper, then science was obliged to listen more closely. The search for clarity began with instruments designed to reach into the deepest silences of the sky. Telescopes were tuned not to visible light, but to the long, stretched frequencies of radio waves, frequencies that carry the faint signature of hydrogen, the most ancient and abundant element in existence. Hydrogen is the storyteller of the early universe. Long before stars fused heavier elements in their fiery cores, hydrogen filled the dark, expanding cosmos. And hydrogen carries with it a special fingerprint, the 21-centimeter line, a spectral whisper produced when the electron in a hydrogen atom flips its orientation. This tiny change emits radiation at a precise wavelength, one that astronomers can track across billions of years as it is stretched by the expansion of spacetime. By measuring this line, astronomers believe they could map the cosmic dark ages, the silent interval after the Big Bang before the birth of the first stars. If the 21-centimeter line could be detected, it would act as a lantern in the darkness, illuminating the era between creation's fireball and the dawn of starlight. It was within this pursuit that the unexpected signal arose. The EGIS antenna had revealed a dip in brightness, as though the hydrogen gas had absorbed more energy than predicted. To test this, other arrays were brought into play. LOFAR, a sprawling network of low-frequency antennas across Europe, joined the search. In India, the SARAS experiment refined its measurements. And soon, preparations intensified for the Square Kilometre Array, the largest radio telescope ever conceived. Stretching across South Africa and Australia, each instrument faced the same monumental challenge. The universe's faintest signals are drowned in a sea of noise. Radio interference from human technology, from Earth's atmosphere, even from our own galaxy, threatens to eclipse the delicate whispers of hydrogen from billions of years ago. Detecting such a signal is like trying to hear the flutter of a moth's wings in the middle of a storm. Yet, through layers of calibration, subtraction, and refinement, patterns began to emerge. The strange dip seen by EGIS is not easily dismissed. Other datasets revealed hints of the same distortion, suggesting it was not merely an illusion. As the investigations deepened, astronomers realized the signal might be more than a single anomaly. It could be the beginning of a larger map, a pattern of absorption features, marking the slow cooling of the universe as it transitioned from darkness to light. If real, these patterns would allow scientists to chart the cosmic dawn itself, tracing how the first stars ignited and reionized the hydrogen fog that filled the cosmos. But there was a problem. The signals did not fit comfortably within existing models. Hydrogen seemed colder than expected, as though something unseen had drawn energy from it. The anomaly grew sharper, not softer. With further study, this raised a haunting possibility, perhaps the interaction between hydrogen and radiation. was being shaped by a force outside the known laws of physics? The deeper astronomers looked, the stranger the story became. One hypothesis suggested that dark matter, normally thought to interact only through gravity, might have brushed against ordinary hydrogen, cooling it in the process. If true, this would mark the first direct evidence of dark matter behaving in a way no experiment on Earth has ever captured. Another speculation pointed toward the very structure of spacetime. Could fluctuations from the inflationary epoch, frozen into the fabric of the cosmos, have left behind subtle imprints that now echo in the hydrogen line? If so, then these signals are not merely about the first stars, they are about the birth of reality itself. The investigation also demanded refinement of instruments. Teams worked to peel away contamination layer by layer, separating human interference from the whispers of the cosmos. Each dataset required years of analysis. Each potential anomaly checked against countless simulations. Through it all, one fact remained. The strange dip, the colder-than-expected signal, refused to vanish. For many, this persistence was both thrilling and terrifying. If the anomaly survived scrutiny, it would mean that the universe's earliest light was not what humanity had believed for half a century. It would mean that the first chapter of cosmic history is incomplete, that the story of light's emergence began earlier under stranger conditions than anyone had dared to imagine. Science thrives on such tension, the edge where data and doubt collide. The deeper the investigation went, the clearer it became that the signal could not be ignored. The universe was not offering easy answers, but it was offering hints, fragments of a puzzle that might one day reveal the truth. And so, astronomers pressed forward, refining instruments, expanding arrays, building ever larger ears to listen. To the silence, they were not chasing noise anymore. They were chasing a contradiction, one that might force humanity to rewrite the origin of light itself. The closer scientists looked, the deeper the mystery became. What began as a faint dip in the radio spectrum, a single distortion in the endless hum of hydrogen, soon expanded into something more profound. The universe, it seemed, was not only whispering but whispering in defiance of everything we thought we understood. The signal revealed itself to be colder than theory could allow. According to established physics, the hydrogen gas in the cosmic dawn should have been warmed by the faint glow of the cosmic microwave background. Instead, it appeared to be frozen, as though touched by an unseen hand that siphoned its warmth away. This was no small discrepancy. It was not the difference of a decimal point, nor the margin of human error. It was a fracture at the foundation of cosmology, a direct contradiction of the models that had held firm for decades. If the observation was true, then something invisible was shaping the infant universe, rewriting its conditions before the first stars had even drawn breath. Dark matter quickly became the prime suspect. For generations, it had lurked as a silent enigma, known only by its gravitational pull on galaxies and clusters. But what if dark matter was not entirely aloof? What if it had brushed against hydrogen atoms in those first moments of cosmic dawn, cooling them in ways never seen since? If so, then this faint anomaly was not just about light. It was the first evidence of an interaction between matter and the hidden scaffolding of the cosmos. And yet, the implications grew stranger still. If dark matter had cooled the gas, it would need to possess properties beyond any current theory. It might be lighter than predicted, more elusive than imagined, a phantom particle bending the rules of physics themselves. Other voices rose with different speculations. Perhaps the signal was not about dark matter at all. Perhaps it was a trace of physics beyond the standard model, hints of forces or particles that no collider on Earth had ever glimpsed. Some wondered if primordial black holes, tiny but ancient, could have played a role, draining energy through interactions we can barely imagine. And then, there was the most unsettling idea, that the anomaly was not simply a physical problem, but a chronological one. If the signal was truly older than the cosmic microwave background, then our timeline of the universe's birth was flawed. The age of light itself, the boundary between darkness and illumination, may not lie where we believe. The thought carried with it a quiet terror. For if the sequence of cosmic history could be wrong in its earliest chapter, then how much else might need rewriting? The deeper the mystery grew, the more it destabilized the human sense of certainty. The Big Bang had always been painted as a singular, orderly story, a violent birth, a cooling fireball, then light and structure emerging in sequence. But this ancient signal hinted at chaos beneath the order, complexity behind the simplicity. It was as though the universe, instead of speaking with one voice, had been layered with overlapping songs, some of which we were only now beginning to hear. For astronomers, this deepening enigma was both thrilling and unnerving. On one hand, it was an opportunity to probe physics beyond Einstein, beyond the frameworks that had guided science for a century. On the other, it was a reminder of just how fragile our understanding remains, how quickly certainty can dissolve when the cosmos chooses to reveal a contradiction. The escalation of the mystery did not end with the coldness of hydrogen. As more data was gathered, subtle irregularities began to emerge, fluctuations in the spectrum that did not align with predictions of when the first stars should have formed. The implication was shocking. The timeline of cosmic dawn itself might be out of place. Perhaps stars were igniting earlier than expected, or perhaps something entirely unknown was shaping the gas long before starlight began. This was not just a question of light. It was a question of the architecture of reality. The hydrogen anomaly became a mirror held up to physics. The standard model, so powerful in describing the visible world, faltered in the face of the invisible. General relativity, Einstein's masterpiece, stood silent against the possibility that unseen interactions were shaping the early cosmos. It was as though the universe had designed a paradox, placing it in the cold silence of space, daring humanity to explain it. And yet, in this escalation of mystery, there was also beauty. For the deeper the anomaly grew, the clearer it became that the cosmos is not a solved equation, but a living question. Each contradiction is not a failure of knowledge, but an invitation to look deeper, to question the very assumptions that define existence. The faint, ancient signal had grown into something more than data. It had become a riddle, one that threatened to overturn the story of light itself. The first dawn of the cosmos, once thought to be a singular moment, now shimmered as a complex and uncertain frontier. The mystery had deepened. The universe had spoken again, and what it said was unsettling. The story of creation is not finished. The script of cosmic dawn is still being written. When a mystery grows too large to ignore, science turns to its most powerful tool, imagination disciplined by evidence. The anomalous signal, colder than theory allowed, older than history permitted, demanded explanations. And though no single idea could claim certainty, the human mind, restless and insatiable, began to weave possibilities from the threads of physics. The first and most compelling theory pointed toward the great unseen majority of the universe, dark matter. For decades, it has been known only through its gravitational pull, the invisible weight that holds galaxies together and bends the paths of light. But what if dark matter is not merely passive? What if, in the tender youth of the cosmos, it brushed against ordinary hydrogen, drawing away heat like an invisible ocean surrounding every atom? To cool the gas so dramatically, dark matter would need properties beyond what most models allow. It might be lighter, moving slower, or capable of exchanging tiny amounts of energy with normal matter. If true, then this faint radio signal is the first direct evidence of dark matter's hand upon the universe. Its silent influence captured not by particle detectors buried deep underground, but by the hydrogen atoms that floated free when no stars yet burned. Others looked deeper still. Perhaps the anomaly is not the work of dark matter, but a reflection of new physics beyond the standard model. The familiar zoo of particles, electrons, quarks, neutrinos may not be the entire cast. Could there be a hidden particle, an unknown mediator, whispering between hydrogen and the cosmic background? Could this signal be its fingerprint, etched into the universe's oldest gas? Still others turn their eyes toward the earliest seconds of creation. The epoch of cosmic inflation, when the universe expanded faster than the speed of light itself, may have left behind scars, ripples, and quantum fields frozen into the fabric of space-time. These scars might subtly shift the conditions of hydrogen, bending the spectrum of ancient radiation in ways we are only now beginning to perceive. If so, then this signal is not just about the first stars, but about the firestorm that created reality. Some ventured even further into the most speculative realms. If our universe is but one bubble in a cosmic multiverse, collisions between universes might have left faint imprints, echoes from beyond our reality. A radio whisper colder than theory predicts could be such an echo, a relic not of our cosmos alone, but of another pressing against it in the deep past. If that is true, then this anomaly is not only a signal from before the first light, but a message from beyond the boundaries of existence itself. Each theory carries its own poetry, its own terror. Dark matter cooling suggests a hidden partner, woven into the fabric of every galaxy. New physics beyond the standard model hints that reality is built from rules we do not yet know. Inflationary relics point back to the very birth scream of the cosmos. And multiverse collisions whisper of countless unseen worlds brushing against our own, yet none of these theories are complete. Each is riddled with uncertainty, each dependent on data that could still prove to be a mirage. The universe speaks in riddles, and science is still learning the language. For some, the speculative nature of these ideas is a weakness. For others, it is a strength, a sign that humanity stands at the frontier of knowledge, where imagination must take the first step before data can follow. What unites all these possibilities is their power to rewrite the story of light. No longer is the cosmic microwave background the unquestioned beginning. Instead, it may be only one voice in a deeper chorus, a chorus shaped by hidden matter, invisible forces, or even universes beyond our own. Theories rise and theories fall, but the signal remains. And so long as it remains, it demands explanation. It demands that humanity look again at its oldest assumptions, that it ask once more the question that has haunted it since the beginning. What is the universe, truly? Speculation is not the end of science, it is the beginning. And in the case of this ancient whisper, speculation may be the only bridge we have to truths that lie beyond our reach. The universe has given us a contradiction. And until it is resolved, theories will continue to bloom like stars in the dark, each one a guess at what the cosmos is trying to tell us. The universe is vast, but its deepest mysteries often hinge on the faintest of signals. To test whether the ancient whisper is real or illusion, humanity has turned its greatest instruments toward the silence of the sky. The search begins not with a single telescope, but with an orchestra of machines stretched across deserts, mountaintops, and even orbit. Each instrument is designed to hear what the human ear never could, frequencies long and low, where hydrogen speaks in whispers billions of years old. The most modest of these was EDGES, a solitary antenna no larger than a dining table, resting quietly in the barren desert of Western Australia. Its simplicity was its strength. Free from the interference of cities, it listened patiently to the sky. And it was there in 2018 that astronomers announced the anomaly, a dip in the spectrum colder than any theory allowed. But extraordinary claims demand extraordinary scrutiny. The scientific community did not accept the signal as truth. Instead, they demanded repetition, verification, and precision. If the universe had spoken, then more ears had to listen. Across Europe, LOFAR, the low-frequency array, stretches its metallic arms across fields and plains, a forest of antennas tuned to the lowest radio bands. It searches not only for hydrogen's whisper, but for patterns, fluctuations, and the faint glow of cosmic dawn. In India, the Saras experiment refines its sensitivity, peeling away layers of terrestrial noise. And soon the Square Kilometre Array, the largest radio observatory ever built, will rise across South Africa and Australia, a project so vast it will span continents. Its purpose: to map the universe's radio sky with unprecedented detail, to settle the question of the anomaly once and for all. But telescopes alone are not enough. Instruments must fight against a storm of interference. Human technology, satellites, cell towers, radar, floods the radio spectrum with artificial noise. Even Earth itself conspires against discovery. The atmosphere, the ionosphere, the magnetic field, all bending and distorting signals before they reach the detectors. To find the truth, astronomers must subtract this noise, layer by layer, until only the faintest cosmic whisper remains. It is a work of patience measured not in months, but in years. Each dataset requires relentless calibration. Each possibility of contamination must be tested, ruled out, and tested again. Was the anomaly a reflection from the ground? A faint echo from the Milky Way? A trick of the instruments themselves? Until every alternative is exhausted, the signal cannot be declared real. And so, the testing continues. The James Webb Space Telescope, though not tuned to hydrogen's radio line, plays a supporting role by probing the earliest galaxies directly. Its deep infrared vision pierces billions of light years, capturing starlight from less than 300 million years after the Big Bang. By comparing Webb's galaxies to the timeline suggested by the hydrogen signal, astronomers can cross-check when the universe's first light truly ignited. If the hydrogen appears colder than expected at the same moment galaxies begin to shine, then the anomaly gains weight. Meanwhile, particle physicists watch closely. If dark matter is indeed responsible for the cooling, then Earth-bound experiments, deep underground detectors like Xenon, Lux Zeppelin, or the upcoming Darwin Project, may one day glimpse the same shadowy interaction. The sky and the Earth, together, form a testing ground for the unseen. What emerges from all this effort is not only data, but humility. The universe guards its secrets fiercely, and it may take decades before certainty is reached. Yet this is the nature of science. The cosmic microwave background itself was once doubted, once dismissed as noise. Only through persistence did it become the cornerstone of modern cosmology. The same may be true here. The tools grow sharper with each generation. Where Aegis used a single antenna, the Square Kilometre Array will use thousands. Where Planck mapped the microwave sky, future missions may map the dark ages themselves, charting every ripple of hydrogen before the first star was born. Every observation, every calibration, every quiet night beneath the stars brings humanity closer to an end. Answer: is the signal real, a whisper from before the dawn? Or is it an illusion, a mirage born of noise and error? Science does not fear either outcome. For to test, to question, to refine is its purpose. If the anomaly fades, knowledge is gained. If it endures, a door is opened, a door into realms of physics and cosmology that have never been seen before. And so, the instruments remain fixed on the sky, listening with patience. They are humanity's ears pressed against the silence of creation, and somewhere in that silence, hidden in the faintest frequencies, the universe is still speaking. The universe has always been a storyteller, but not one whose words are easily understood. Its tales are written in the language of light and time, whispered across billions of years, hidden in patterns too faint for the untrained eye. And now, with the detection of a signal older than the cosmic microwave background, that story becomes more complex, more profound than humanity has ever imagined. What does it mean for light itself to predate the first light? Perhaps our understanding of beginnings is incomplete. Perhaps creation was not a single moment of illumination, but a layered process, a crescendo of energy stretching across epochs we cannot yet fully comprehend. Each photon, each ancient ripple is a fragment of a memory older than our ancestors, older than the stars that first burned in the darkness. This signal challenges more than physics. It challenges perspective. For centuries, humans have looked outward and backward, imagining a universe governed by elegant laws, where time flows like a river from a defined origin. But what if the river is braided, splitting into currents that began long before our comprehension? What if the cosmos had a voice before the moment we thought it first spoke, and we are only now beginning to hear the faint echo? The philosophical implications are staggering. Light is not merely a physical phenomenon. It is a record, a witness to the existence of matter, the structure of space, and the unfolding of time itself. If its origin is older than previously believed, then the narrative of the cosmos, the story of birth, evolution, and eventual decay, must be rewritten. Humanity, in its smallness, has glimpsed a truth so vast it humbles the mind. The universe remembers. And we, by listening, are invited to remember with it. This signal also reflects on the limits of human knowledge. For all our technology, our mathematics, our ingenuity, there remain boundaries we cannot cross. We can measure the faintest hydrogen ripple, model the earliest galaxies, trace the expansion of space. Yet, even as we refine our instruments, the universe holds back, keeping some of its secrets hidden, whispering them only in contradictions, anomalies, and faint echoes, and there is beauty in this restraint. The cosmos does not give itself freely. Its poetry is not in certainty, but in the pursuit of understanding, in the patient listening that stretches across generations. Every anomaly, every unexplained signal, is an invitation to wonder, a reminder that discovery is never final, that knowledge is a horizon forever receding. The ancient light also invites reflection on humanity's place in the vast expanse. We are observers, fragile and fleeting, pressing our ears against the silence of billions of years. Yet, despite our transience, we are capable of grasping fragments of the universe's memory. In this act of listening, in this pursuit of understanding, there is connection. The cosmos may be indifferent, vast, and unknowable, but through these faint signals, it engages us in a conversation that transcends time itself. As the telescopes continue their vigil, and as data accumulates, humanity stands on the threshold of revelation. The signal may eventually yield its secrets, or it may continue to elude explanation, forever teasing the edge of comprehension. Either way, the encounter changes us. It teaches patience, humility, and reverence. It reminds us that the universe is more ancient, more mysterious, and more alive than we ever imagined. In the end, the question is not simply what the signal is, but what it evokes: awe, curiosity, and wonder at the vast tapestry of existence. If light existed before what we called the beginning, then perhaps our notion of beginnings is incomplete. Perhaps the cosmos itself is eternal, layered with histories we are only beginning to touch, and in that reflection lies a quiet hope, that by listening, by pursuing the faintest echoes, we may come to know not only the universe, but our own place within its boundless story. In the silence of deep space, as the photons travel across billions of years to reach our instruments, the universe whispers again, and we, for a fleeting instant, are able to hear the story of light, of beginnings, and of existence itself. Continues, waiting for those who are willing to listen, patient enough to hear what the cosmos has kept hidden, and humble enough to understand that even in our discoveries, the universe remains infinitely more vast, infinitely more mysterious than we could ever imagine.